calculate voltage drop for parallel conductors, you need to follow a few key steps. Firstly, calculate the total current. This involves summing the currents flowing through each conductor. The formula for this is total current I equals I1 plus I2 plus I3, and so on, up to N. Secondly, calculate the total resistance. This is achieved by dividing the total voltage drop V by the total current I. The formula here is total resistance R equals V divided by I. Thirdly, calculate the voltage drop per conductor. This is done by multiplying the total resistance by the current flowing through each conductor. The formulas of voltage drop per conductor V1 equals R times I1, voltage drop per conductor V2 equals R times I2, voltage drop per conductor V3 equals R times I3, and so on, up to voltage drop per conductor Vn equals R times N. Let's illustrate this with an example. Consider 3 parallel conductors carrying currents of 5 amps, 10 amps, and 15 amps respectively. The total voltage drop across the conductors is 12 volts. 1. Calculate the total current. 5 amps plus 10 amps plus 15 amps equals 30 amps. 2. Calculate the total resistance. 12 volts divided by 30 amps equals 0.4 ohms. 3. Calculate the voltage drops per conductor. For conductor 1, 0.4 ohms times 5 amps equals 2 volts. For conductor 2, 0.4 ohms times 10 amps equals 4 volts. For conductor 3, 0.4 ohms times 15 amps equals 6 volts. It's important to note that the voltage drop across each conductor is inversely proportional to the current flowing through it, and the voltage drop across parallel conductors is always less than the voltage drop across any single conductor if it were carrying the entire load. This method applies universally, regardless of the number of parallel conductors or the specific values of current and voltage drop. Remember to always use consistent units, such as amps for current, volts for voltage, and ohms for resistance to ensure accurate calculations. When dealing with electrical circuits, safety is paramount. Always consult with a qualified electrician for any work involving electrical systems. This calculation provides a theoretical understanding of voltage drop in parallel conductors, but practical applications may involve additional factors such as conductor length, temperature, and material properties. The accuracy of these calculations depends on the precision of the input values. Small variations in current or voltage can lead to noticeable differences in the calculated voltage drop. Understanding the relationship between current, resistance, and voltage drop is crucial for designing and maintaining efficient and safe electrical systems. Voltage drop can affect the performance of electrical equipment, so it's important to keep it within acceptable limits. This can be achieved by using appropriately sized conductors and minimizing the length of the circuit. In parallel conductor systems, ensuring equal current distribution is important. Unequal current distribution can lead to uneven voltage drops and potentially overload one or more conductors. Factors that can affect current distribution include conductor length, size, and material. To ensure equal current distribution, it's recommended to use conductors of the same length, size, and material for each parallel run. Also, proper termination techniques are essential to minimize resistance at connection points. High resistance connections can cause localized heating and voltage drop. Regular inspections of electrical connections can help identify and address potential problems before they lead to more serious issues. The principles of voltage drop calculation also apply to other types of electrical circuits, such as series circuits and combination circuits. However, the specific formulas and methods may differ depending on the circuit configuration. Understanding the fundamentals of circuit analysis is essential for solving more complex electrical problems. There are several online calculators and software tools available that can assist with voltage drop calculations. These tools can simplify the process and reduce the risk of errors. However, it's important to understand the underlying principles and verify the results obtained from these tools. Electrical codes and standards, such as the National Electrical Code (NEC), provide guidelines for voltage drop limits in various types of circuits. These guidelines are intended to ensure safe and efficient operation of electrical systems. Familiarizing yourself with these codes and standards is essential for anyone involved in electrical work. In addition to voltage drop, other factors to consider when designing electrical circuits include ampacity, short circuit current rating, and grounding. Ampacity refers to the current carrying capacity of a conductor. Short circuit current rating refers to the maximum current that a circuit can withstand during a short circuit fault. Grounding is a safety measure that helps protect against electrical shock. A well-designed electrical system will take into account all of these factors to ensure safety, reliability, and efficiency. Understanding the principles of voltage drop calculation is just one aspect of electrical engineering. There are many other areas of knowledge and expertise required to design, install, and maintain electrical systems. Continuous learning and professional development are essential for staying up to date with the latest technologies and best practices. When working with electrical circuits, always follow safety precautions to prevent electrical shock and other hazards. To energize circuits before working on them, use appropriate personal protective equipment and follow lockout/tagout procedures. Electrical safety is a critical aspect of electrical work, and it should never be compromised. The use of parallel conductors is often employed when the required current exceeds the ampacity of a single conductor. This allows for the distribution of current across multiple conductors, reducing the load on each individual conductor and minimizing voltage drop. However, it's important to ensure that the parallel conductors are properly sized and installed to ensure equal current distribution and prevent overloading. In some cases, it may be necessary to use larger conductors or increase the number of parallel runs to meet the current requirements and minimize voltage drop. The choice of conductor material also affects voltage drop. Copper conductors have a lower resistance than aluminum conductors, so they would typically result in lower voltage drop for the same current and conductor size. However, copper conductors are also more expensive than aluminum conductors, so the choice of material will depend on the specific application and cost considerations. In addition to conductor size and material, the length of the conductor also affects voltage drop. The longer the conductor, the greater the voltage drop for the same current and conductor size. Therefore, it's important to minimize conductor length whenever possible to reduce voltage drop. This can be achieved by locating electrical equipment closer to the power source and using shorter circuit runs. The ambient temperature also affects the resistance of conductors. As the temperature increases, the resistance of the conductor also increases, which can lead to increased voltage drop. Therefore, it's important to consider the ambient temperature when calculating voltage drop, especially in high-temperature environments. Voltage drop calculations are typically performed using simplified formulas that assume a constant conductor temperature. However, in reality, the conductor temperature may vary depending on the load current and ambient temperature. For more accurate voltage drop calculations, it may be necessary to use more sophisticated software tools that take into account the effects of temperature on conductor resistance. In addition to the voltage drop in the conductors themselves, there may also be voltage drop in other components of the circuit, such as transformers, fuses, and circuit breakers. These voltage drops can also contribute to the overall voltage drop in the circuit and should be considered when performing voltage drop calculations. The voltage drop in transformers depends on the transformer's impedance and the load current. The voltage drop in fuses and circuit breakers depends on their resistance and the load current. To minimize voltage drop, it's important to select components with low impedance and resistance. In some cases, it may be necessary to use voltage regulators to maintain a constant voltage at the load. Voltage regulators are electronic devices that automatically adjust the voltage to compensate for voltage drop in the circuit. They are often used in sensitive electronic equipment that requires a stable voltage supply. There are different types of voltage regulators available, each with its own advantages and disadvantages. The choice of voltage regulator will depend on the specific application and requirements. Understanding the principles of voltage drop calculation is essential for designing efficient and reliable electrical systems. By carefully considering the factors that affect voltage drop, such as conductor size, material, length, temperature, and component impedance, it's possible to minimize voltage drop and ensure that electrical equipment receives the proper voltage for optimal performance. Regular maintenance and inspection of electrical systems can also help identify and address potential voltage drop problems before they lead to equipment failure or other issues. This includes checking connections for tightness, inspecting conductors for damage, and measuring voltage levels at various points in the circuit. By taking these steps, it's possible to ensure the long-term reliability and efficiency of electrical systems. Remember to always consult with a qualified electrician for any work involving electrical systems. Electrical work can be dangerous, and it's important to follow safety precautions to prevent electrical shock and other hazards. A qualified electrician will have the knowledge and experience necessary to design, install, and maintain electrical systems safely and effectively. By following these guidelines, you can ensure that your electrical systems are safe, reliable, and efficient. The information provided in this narration is intended for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician for any specific electrical needs or concerns. Remember, safety is paramount when working with electricity. Always take precautions to protect yourself and others from electrical hazards.